Okay, so hey guys, it's day 7 of doing Leetcode daily until I get a job. So let's start with today's questions. So we are at the binary search section and we have done the 4 questions and now the 3 are left. So we'll be doing these 3 today. That's medium, medium and hard. And one more thing, the question we were doing yesterday, search a 2D matrix, so there was a error in our first approach that we did and it gave us the heap buffer overflow error and we were noticing that we are not able to find the correct row in which we need to search. Okay, we were applying the binary search correctly, but we were not able to find the correct row. So I found the error in it after some time while I was debugging it. So it was like this, that there were two basically errors in our questions which we were doing. First is there should be an equal sign here, that if it is even equal to the target, then we have to take that row only. There were no condition for the equal sign. Okay, for the equal sign it was going to the else, and which was a wrong approach to do. If it gives a equal, we have to have the same row. We have to check the same row. Okay, or we can do is, what we can do is like, if even other than that, we can have it like, if we have it equal to the target, then we can return true right here. Okay, that's one thing. After that, if this is not the case, then it will go to here, row will go to here. Okay, now we have to make a check on the row, that if this row it should be less than, it should be greater than, it should be less than actually the matrix size -1. Okay, and if it is greater than that, then it's going out of bound for us. That's why it was giving heap buffer overflow error. And if we check here, and if it's going out of bound, we will return false and it will give us a correct solution. That's sweet, 100%. Okay, so that was the error in yesterday's question. So let's start with today's questions. First is search array, rotated sorted array. So there was a similar question yesterday, which was finding the minimum element in a rotated sorted array. Okay, now we have to find the a target if it exists in this sorted array. So we'll again apply. Uh, we are gonna again apply the binary search here. Okay, so this is our input. So what we can do here is that we will simply firstly apply the binary search only, that low is 0 and high is 6. Okay, so the mid is 3. This is where we are currently. So now here we will check if the low is less than this mid. What will it tell us? It will tell us that between low and mid it is a sorted array. If low is lower than mid, then it must be a sorted array. This half must be a sorted array. Okay, so then we'll check if this target exists in this part. Like, this is a sorted array, we can apply the binary search here, but we have to check now if this array, if this target even exists here or not. If it exists here, then we will keep this high here and then we will search. Okay, if it is equal to the mid, we will just return it. So if it's not equal to mid, obviously, if it belongs to this range, then we will put the high here. And if it doesn't, like 0 doesn't belongs to this range, then we will put the low here, low at 0. Okay, now our low is 4 and our high is 6. Okay, because 0 belongs to, obviously 0 is not in this range, so we will shift the low to mid plus 1. Okay, now we will check if our low, now our mid is what, 1. So we will check if our low is higher than mid or lower than mid. Our low is lower than mid, obviously, so we will have this range only now. So we will shift the high, to mid -1, means here. So now both low and high are at 4, so mid will be also 4. So if nums mid is equal to the target, yes it is. So we have the return answer. But let's take another example if we are given here. Okay, Okay, in this case what will happen is that it still doesn't belong to this range. Okay, nums low to mid, so low will become 0 and high will become 2. Now we'll check if low is less than mid. Yes it is, but 3 doesn't belong to this range 0 to 1, so we will put the low to 2 here. Okay, we will put the low to 2 here, and mid will be this only 6, and if the mid is 6, nums it's not equal to the target, low is same, high is same, and mid is same, and low and mid are equal. We will check here, it doesn't belong to here, so nums will be it doesn't belong here, right? It's lower than the target, so we will do a low as mid plus 1, and it will be higher than the high, so the loop will break and will return minus 1 here because it doesn't exist here. Okay, so let's start doing it. So employee is 0 and high is nums dot size minus 1. Now while low is less or equal to high, we have to firstly do this. Okay, we got the mid. If nums mid equals the target, then we will just return the, we have to return the index, right? We have to return give the nums after the positive, return the index. Okay, return mid. If it's not, then we have to check that if nums low is less or equal to nums mid. If it is, then this is a valid section where we can apply the binary search. Then we will check if the target is greater or equal to nums low, and the target must be less than nums mid, because it's not equal to nums mid. If it was, then it will have returned false, returned here. Okay, if it is coming here, it's not equal to mid. So if it is in this range, then we will do high as mid minus 1, and else low as mid plus 1. Now this is one situation, but what if this is not true? In our examples this is being true. Okay, let's take an example here, and 6 by 2 3. Okay, let's remove 7 from here. Okay, how to do things. Okay, let's just remove the 7 from here. Okay, let's just see if 7 is not here. Okay, now our mid comes where? 1 2 3 6 elements, 6 by 2 3. Our mid is here. So now check if nums low is less than nums mid. Nums low is not less than nums mid. If this condition is not true, we have to have another condition, right? And that condition will be, that condition is obviously that if it is not true, if this situation is not true, that this is not a sorted array, then we will check the other side, obviously. Okay, and we will check if this target exists between nums low and nums mid and nums high. If the target exists between these two. Okay, nums mid, if anyways it's equal to nums mid, but let's just say that it was like say 1 2 3, it is there, not 0 1 2, and we have to search for 2. Okay, so we have this as the mid and this as the high. We will see, yeah, it belongs in this range, then we will check in this range. Similarly we did here. Okay, now we will check the range first, that if the above condition is not true, we will come below, and if target is greater or equal to nums mid, greater than nums mid, and target is less or equal to nums high, then what we will do? We will do this, else high is mid minus 1. Yeah, this is the thing. And if nothing happens still, then we will just return minus 1. This should be fine. Okay, 0 here, brother. 0 online in this question. Nobody is doing this question. Oh my, I'm the only one. Okay, I think that's it. Yeah, we got it. Next is the time-based key value store. Okay, design a time-based key value data structure that can store multiple values for the same key, like a hash map. Okay, at different timestamps and retrieve the key value at the certain timestamp. Means we have to design something similar to a hash map. Okay. And in that hash map, what we need to do is we are given two things for a key. One is its value and one is its timestamp. And when we will be given a key and a timestamp, we have to provide that value. Okay. So let's just make another map. And string will be its key, right? And we have the timestamp and the value in the value part of this key. So let's make a map here, and it will be, because timestamp is a string, int, and it will be a string. The reason why we put a map here is so that we can sort it according to the timestamp. Do we need the sorting button? Timestamp, time initialize the object of the structure void set string key value stores the key with the value at the given timestamp. Okay, this is a normal push thing. When we are getting it, return the value of the set. Such set was called previously with timestamp priv less than timestamp. If there are multiple such values, we return the value associated with the largest timestamp priv. Okay, so let's say on the same timestamp we have multiple things, multiple values for the same timestamp in a key. Okay, so we'll go in that key and we have to give the last value for that timestamp we have in that. Okay, for a timestamp we can go to, we will go to the upper bound of the timestamp. See, upper bound for any value in a array or anything means that the value just greater than the given value. Upper bound of a value means the value just next to that value, just greater than this value. Okay, and if we just take a step back from the upper bound, we are on the last value for a particular timestamp. Okay, this is what we need to have, right? While setting, it's easy that MP of key and timestamp MP of that key timestamp dot push, or we should be like equal to value. Hey, Choco. My dog is there. Okay, so while getting it, we can do it like let's have an iterator, because upper bound returns an iterator obviously. Okay, iterator as equal to of that key dot upper bound of the given timestamp. Okay, now this iterator reaches us where the timestamp we need to have, the value we need to have just next step from that. Okay, and we have to come back one time. Okay, then we will just do iterated minus minus. Now we are here and we have to just return what? Iterator second value of it, means the value of it, this value. First is the timestamp, second is the value. Okay, not second. And one thing is, if we do not find that value, if we do not find any value for that timestamp in that key, what we need to do then is, then the iterator will stay at the beginning. So if iterator equal to uh, mp dot begin, uh, mp key dot begin. If it remains at the beginning only, then we have to return empty string. Right, let's try running it. Yeah, I think we got it. Yes, done. Next is a hard question. Let's go for it. Median of two sorted arrays. See, while looking at it, it seems like a simple question, but it is a really good question. I remember doing it for the first time, and it was a really typical question. I still have the approach in my mind, like what I did, not the code actually, but let's try to do it with an example. Okay. Okay. So let's say we have this array. First is 1, 2, 2, 3, 4, 5, 6, and 7 and 8. Okay, this is the first. Fine. And let's take another vector, and let's take 1, 2, 3, 4, 5. Okay, these are the two vectors we have. Now we have to mix them up and uh, find out the median of these two sorted vectors. So when we sort them, when we like merge them, see, one method is very simple. Let me write it down. 3, 3, 4, 4, 5, 5, 6, 7, 8. Okay. One method is really simple, is that we just merge them up and we will sort that overall vector and we will find the median. But that is what a bad approach looks like, because that will be very costly to do, because log n directly goes with the sorting of that array, and we have to do it in O log of m plus n. So basically we can see that we have to apply some other approach so that we do not have to iterate the whole fucking array. Okay, so we have this here. So what we can do is, one thing we can see, median is the middle element, so there will be some elements, there will be a number of elements before that median, like there are odd number of elements, so there will be 6 elements before and 6 elements after, and this is the median we have. Okay, so one thing is for sure, that this length is 13. Our partitions will be 6 each. We are taking the odd case here, 6 each. Okay, now for this 6 each means the first 6 elements, we need to find this partition. Okay, first 6 element. So for this 6 elements, some element will be from here and some element will be from here. That's a fixed thing, right? From both the vectors, some element will be taken for the first partition, for some for the second partition. Now what happens will be, if we decide that in the first partition how many elements we will be taking from this vector, then we know that how many elements for the first partition we have to take from this vector. Let's say we will be taking 3 elements from this vector for the first partition, then rest of the 3 elements must be from here, right? So that half 6 is the value for length of each partition. And now we need to find how many elements we will be taking from this array. Okay, so let's try to find this through an approach. Okay, so apply the let's say its length is n, so 0 index. Okay, let's apply the binary search on this one. When we binary search apply this, this is the mid. So let's just say low to mid. This is the length. These are the elements we will be taking for the first partition from this array. Okay, 1, 2, and 3. So how many elements we need to take from here? 6 minus this length 3. 3. We'll be taking 3 elements from here. Now, at this point, see, if these both combines as the first partition, then rest of the elements are in the second partition or the medium. Okay, and all the rest of the elements must be greater than the greater element of this combination, right? Let's see just that now if these are the left partition, the right partition will start from here or here, but in this case these both are equal, so it doesn't matter which element we take, but the just next element of this left partition will be 4. Okay, so this element must be greater than this element, and this element must be greater than this element. Why so? Because these elements belongs to the left partition and these elements belongs to the right partition. So every element of this left partition must be smaller than every element of right partition. So the largest element of left partition will be either this element or this element, because they are sorted in their own arrays, but it can be the greatest, it can be the greatest. In this case they are equal, but let's just say, okay, so it is obviously smaller than its own array's element, but we don't know about the other array's right side partition element. So if it is less than that, we are good. If it is also less than that, we are also good. Then we know that we have done a perfect partition. There is no flaw in this. So we have the partitions now. And if this condition holds true, what we have to do? If the length is odd, then there will be only one median element, and that will be the first element just right of the left partition. Means these remaining elements, the greatest element, the smallest element from these remaining element will be the median. So it will be either this or this, because rest of the elements are greater in their own arrays. So we have to just take minimum of these two elements, and that will be our median. This is the case when we have to like do nothing actually. We were at a good partition at the first stop, and also like it's an odd case. So let's take a even case now. Let's just take a even case. Okay. Okay, now let's remove this 5. Okay, let's remove this 5. Now we have 4 elements here, and we have a total of 12 elements. Partition is still 6, but the thing is in this array there will be only 1 4, and okay, there will be 2 partitions, these 2. Okay, 6 6, there will be no median. Okay, now again we will apply the binary search on this one, 0, and when we apply the binary search, 4 0 plus 3 is this n, and 0 and minus 1, obviously this is n minus 1. So 0 plus 3 by 2 1. This is the mid, this is our mid, right? So this is our length we are taking from the first array for the left partition, that is length is 2, but the length is 6, so rest of the 4 elements will be from here. Now what we will check is that if this element is less than this and this element is less than this, 2 is less than 5, good, but 4 is not less than 3. So we cannot include 4 in the left partition when we have 3 in the right partition. Okay, you getting it, right? Because that needs to be sorted. So this case is false. We cannot. We were taking a wrong partition. Now what we need to do? we will just, what we will do is that we will, in this case, 4 4 cannot be there, right, in the left partition. Then this means that there must be more elements from the, let's see, see which comparison failed. This comparison failed, na? Okay, if the mid plus one element of the first array is less than this element of which is we are including in the uh, left partition, then what we need to do, we need more elements from this array, first array, so that there will be less element from this array, so it can be less than so it can, the length can be this side, so that 4 cannot be included. Okay, so that's why we will do what, we need more element from here, so we will shift the low which was here initially to mid plus 1. Okay, so now here is our low and here is our high of for the binary search. So it is 2 plus 3, 5 by 2, 2. 2 is this, so this will be our partition from the left array, and if this length is 3, then what we will be taking from the second array? What we will be taking from the second array is this length. Sorry. Yeah, this length we will be taking 3 and 3. Okay, now let's compare. It is less than this, 3 is less than 4, 3 is less than 4. So correct, we have it. Now we have the left partition and we have the right partition, but the length is even now, 12 is the length. So we will do what, the minimum of these two elements and the maximum of these two elements, and divide them by 2 by adding them. 3 plus 4 by 2, 3.5. This is our answer. So this is the way of doing it. Really a complex question, but let's try to code it. And this approach is really good, and that's a very good question. So we need to understand it, how this approach is working. Simple approaches are there, but that won't be efficient enough. So firstly, we need to know which array is shorter, which array length is shorter. Okay, let's say n is the nums 1 length, nums 1 sort size, and m is nums 2 dot size. Okay, and if n is greater than m, then just we will invert them and we will send this. Okay, now and total length is, total is what, n plus m. Okay, n plus m, and into half is total by 2. Okay, we have the half here. Now we need to apply the, now int low is 0, high is n, right? High is n, or it must be n minus 1, right? Yeah, it must be n minus 1. Okay, now while low is less or equal to high, what we need to do now, we will first find mid. Mid is what, low plus high by 2. We have the mid, and we have the mid. Low to mid is the first length, and so leftmost element from first array, leftmost element from first array, and rightmost element so rightmost element from first array. For this we are only talking about this partition. Okay, we will never talk about this partition, we are just keeping in mind this partition. So what is the leftmost element from first array which is in this partition? This is 3. So this is our first variable. So we will take the first array as a left. It will be equal to a left will be equal to what? See. So the index, this index. हाँ मैं बोलियो मत अभी बोलियो मत. So this index from the first array. How do we find this? We will just let's say name it as C1 this and C2 this. That will be half minus C1. But wait, it will be 3 by 2, 1, 6 minus 1. By 2 here, and 6 minus 1, 5 minus 1, 4 and minus 1, 2. Okay, we have to minus 2 here. You will get with time like why we are doing minus 2, because this must be an index. Okay, half is the length, c1 is the index, and it should be an index. So minus 1 for this, minus 1 for the index, c2 should be, so minus 2 is here. We will get the correct value, don't worry about that. So okay, so now if c1 is 0, means there is no left, there is nothing on the left side of it, then we will put it as int min. Okay, else what we have here is nums1 c1. Okay, less than 1 it should be. Wait, okay, let's try. Let's see at last if we get it right. And right will be if c1 is less than 1, then it will be okay, c1 is greater than n minus 1, then it will be into x, else it will be nums1 c1 plus 1. Okay, so we can also write this if c1 plus 1 is greater than n. Actually n minus 1, in fact. It is equal to 0. Yeah, we are good. Less than 0, obviously, less than 0. Yeah, we have to just keep track of the indexes. And then B left and B right. So if C2 is less than 0, int min, otherwise nums2 C2. B right will be C2 plus 1 is greater than M minus 1 nums2 and C2. Okay, now we have these. Now we have to check if the condition will be A left must be less or equal to B right, and A right must be less or equal to, must be greater or equal to B left. If it is so, then we will check if total is odd, then we will return what? We will return max of A left and B left plus min of A right plus or b right, and them divided by 2.0. It should be a double, okay. And if it's that, if it's even, if it's an odd, then just min of a right and b right will be doing the job. Okay. Now if this situation is, if this condition is not true, then else if the a left, or we can say L1, means a left is greater than, a left is greater than, a left is greater than this, then we have too much elements here from the first array, we have to decrease them, is greater than b right, then we will do what, high is equal to then c1 minus 1, and else low is equal to c1 plus 1. This should do the thing 0.0, will it? Okay, we have the wrong answer as 0.00. Where is it, sir? Your correct answer in this case, right? Why is it giving us 0? I'm sorry, 2 is 1 and one, 3 and 2. Okay. एलिमेंट से ये एलिमेंट हमने मान लिया कि आएगा ही. अब इनका मिड कितना है, एक ही होगा. What should be happening in this case now? So this must be less than these elements, but it is not. So if it is not, high will be shifted. Okay. We are doing less than 0. But what if it's equal to 0? If nums2 is equals to 0, num0, c1 is already 0, then it should be into min. I guess we should do it even for the case of 0. I think so. Okay, it overflowed. Yeah, it overflowed because of this integer minimum negative infinity. C1 is obviously going to be 0, because left is 0, right is 0. What if we do this? 0, it will be half 1 minus c1 is 0. c2 will be minus 1, right? c2 is minus 1 in this case. This will equal. What will be happening here? Let's see. Let's put it as 0 only. If it reaches 0, it will do it, and if it reaches 7 plus 1 and minus 1. Oh. E buffer overflow at this position is greater than n. Let's put high as this and remove this. Okay, what it will do is it will be still 0. 0 plus 1 by 2. C1 is 0 and half is 1. 1 minus 0, 1. Okay, and let's put it as C1 minus 1. And this is C1 and C2 minus 1 and this is C2. Okay, I think this should do the thing. I will explain it. Let's just firstly submit it and see if it's correct. Yeah, it's correct. Okay. See, what we were doing wrong is that when it was 0, C1 was 0, then half is 1 in this first test case, and this test case, half is 1 because total elements are 3. 3 by 2, 1. 1 is half. So half 1 minus C1. C1 is 0. 1 minus 0 and minus 2. So C2 was minus 1 here. Okay, if C2 is minus 1, but it is not equal to 0. Okay, so it will go here. Minus 1, minus 1. It's going out of bounds. That's why here. Second thing is C1 is 0. Then it's int min. And it will be, if it's int min. Okay, see the first case now only. C2 is what? 1. C1 is 0. C1 0. So A left will be int min. A right will be C1 is 0. If C1 is 0, 0 plus 1, 1 is greater than 1? No, it's not. So it will be nums C1. C1 is 0. Okay, nums 0. So A right will be 2. B left will be C2 is 1. B right will be this 1, and B left will be, and B right will be 3. Okay, so 1 and 3 are there, and here int min and 2. So int min must be less than 3, 1 must be less than 2. Yeah, it's correct. It's correct, right? So we don't have to, if this condition holds, then what we will do is that, yeah, it's odd. So we will come here. So we have just to minimum the A right or B right. A right is 2, B right is 3. Minimum of these are 2. So 2 will be returned here. So that's why it's correct. Okay. That's why it is correct. So yeah, that's done. That was pretty good thing, but see, code can be done. There might be errors, but it can be like fixed in some time. But the main thing is the approach we are taking. If the approach is wrong, it will take ages for us to track back to our mistakes. So the approach should be correct. Code can be done. There is no problem with the code. So we have done the 3 questions today. 2 of them are 100%. Good one. So yeah. Okay, and I'll also be starting a new series of questions, which will be this CSCS questions problem set. We have a pretty popular problem set that's basically based on competitive programming. So we'll try to do this. We'll be doing this daily also, and we will see like in what format we will be doing. Like we'll be doing with a fixed time frame, or we'll be setting a number of questions we need to attempt in a day. Yeah, we'll see how we do it, but yeah, that's it for this video, and it took us 44 minutes. Okay, it was nice. So that's it for today. What we'll be taking on tomorrow is after binary search. This is the first list, guys. We'll be doing a lot more after this. Next is the sliding window. It has 6 questions. Yeah, we'll divide somehow. Maybe we are doing this 4 one day and these 2 the next day. Okay, so that's it for today. Thank you.